Good morning, everyone. My name is Jake, and today I'll be talking about Gen AI agents with an AI assistant demo. And to give you a brief introduction, I am a Gen C volunteer. So at Gen C, we work with new generative AI applications where we partner with AWS. To give a quick idea of what we'll be covering today, so first I'll talk about introduction to AI agents. Then I'll move on to AI agent frameworks. So I don't know how many of you have heard LangChain, Amazon, Bedrock, and many others. Then I'll talk about some real-world use cases, followed by a demo that I created, and I will end off with some questions Q&A. So first, introduction to AI agents. While researching this topic, I always wondered, what is the definition of an AI agent? So an AI agent is something where software programs can interact with the environment, and it uses large language models to do so. So if you see in the diagram I have below, the brain is where we store large language models, and these software programs can interact with the environment using things called actions. And in many frameworks, they call these action tools. And another thing common that many AI agents use is a RAG to extract text information about the environment, and these data sources can change. So in this example, the environment is actually the outside world, and the agent is able to get the weather from an API call. So this is a common use case of AI agents. Yeah, so besides that, AI agents can collect and use past data and perform tasks based on rational decisions. So moving on, I was trying to understand a common framework of AI agents, and I could not really find a definitive answer because AI agents are very new and many different frameworks and companies have different ideas. So I'll give you a brief idea of what I think are the components of an AI agent. And the diagram on the left is something that I took from NVIDIA. Yeah, so first and foremost, the core of the AI agent is a large language model. So this large language model helps with input processing and understanding the queries. And once it understands the queries, it can generate a response. And this response can actually utilize tools. So tools are like actions or APIs, which the large language model can do. So if you see in the picture, the large language model has access to an action. So what this means is that it can do things like access the web, it can do analytics and even some math calculations. So why is this important? So math calculations are often quite difficult for AI large language models to do. Like a common question is 1.11 bigger or 1.09? And in the past, a lot of large language models have trouble to figure out what is bigger, but even if you use a small model and you are able to use these tools, you can actually achieve the same result without hallucination. Yeah. And another cool thing about tools is you can use it for communication, like sending email or using API with other applications. Yeah. So moving on, so in this diagram, you can see that it can perform the actions. And also another thing is that in many cases, large language models can interact with databases and vector database. So as a few of my past colleagues have came up to talk about RAG, which is retrieval augmented generation. So this is something that many agentic large language models use to help them interact with the environment. So another thing that I'd like you to take note of is this data flywheel. So this means that these AI agents also work with changing data, and you can even customize this AI agent to adapt to a changing environment. And why this is interesting is because they can solve more complex problems, and as problems change, these AI agents can adapt to also solve them as well. So this next slide is about multi-AI agent systems. And this diagram is something that I found from a research paper, which shows a simulated agent society. So in many demos and use cases, it's usually very simple agents, and a simulated agent society is something where we can solve more complex tasks with many agents. So in this agent society, they can interact with other agents in collaborative or even competitive ways, just like humans. And they interact with a virtual environment like Minecraft or the physical environment using robots to solve more complex problems. And the way they get the data is through humans, and even they have um, uh, tools to work on the environment. So one more thing that I'd like to point out is that you can even give some of these agents a personality. So these personalities could be like a manager to manage a group of other agents, or a researcher, an agent that is very good at researching about new things. And these specializations and skills can actually help solve more problems. So now I'll move on to agent frameworks. In this presentation, I've researched about 6 frameworks. So I'm sure you've heard of some, the most popular being LangChain, AutoGen by Microsoft. So the first line shows their name, followed by something interesting about these different frameworks. And lastly, I just wanted to highlight that in most cases, the actions that agents take are defined by tools, but for Bedrock, we use something else called action group. Yeah, so Crew AI is a framework that is open source as well. We have Llama Index, which is tied with the popular large language model Ollama. And one thing interesting about Llama Index is that you can run it on your local model. So if you have a RTX 4090 or like me a 4080, I've actually ran a Llama model, and I can actually use Llama Index to run my agent frameworks. Yeah, so Bedrock is really good for AWS integration, which I'll show you later on. AutoGen has something called agent types, where something like agent personalities, or you can specify more about an agent. LangChain, as the name suggests, is chaining different components together to achieve your outcome that you want. And dynamic is something that I thought was quite interesting because it's popular and it's low code. So nowadays you don't even have to code to create an agentic system. So today I'll go through 3 of these frameworks, Crew AI, LangChain, and Bedrock. Okay, so moving on, in Crew AI, as the name suggests, there is a crew. So a crew is something where you have a few AI agents, the tools that these AI agents can do, and tasks. So task is something like what you want the outcome of the agent to do. And you can have many different tasks and many AI agents, each with many tools. So to define an agent, you can give them their role, which the large language model will be the brains and figure out what they have to achieve. You can give them a goal, which guides their decision making, and a backstory to give more personality, which I mentioned earlier. And yeah, the other things are optional, and the tools, which is a list of functions that the agents can use. So another thing interesting is these agents can actually delegate tasks to other agents in their crew to solve problems together. Next, we have process. So process is just the workflow, and there's only one process. So there's 2 types. We have sequential, which means we execute task in system, and hierarchical process, where the manager actually assigns the task, or it solves it in a hierarchical way so it can be solved in parallel. So here to define a task, we can first give a description so that the large language model will know what the task is about and expected output. So usually task is something you want to achieve. And from working backwards, the agent can figure out the best way to achieve that. Yep. So the tools also what this agent is used for this task. So I think that's something very interesting because certain tasks you want to limit it to a certain set of tools because other tools may actually not help, but the agent might not know this. So this is a way to kind of make sure that the agent gets the correct idea. Yeah, and task helps the crew to be collaborative and you can actually assign, other agents can assign each other a task. Yeah, so that is all for Crew AI. Next, I'll move on to LangChain. So there's LangChain, LangSmith, um, LangServe, and sometimes there are new Lang something coming out. So maybe to give you a brief idea, each one's have their own specialization and also what they're used for. So LangSmith is more to monitor, feedback, evaluate. So if you deploy an agentic framework and you want to in production, you want to observe it, debug it, you use LangSmith. So LangChain here is where you can chain agents and advanced retrieval strategies. And with LangChain, you have a community, you have a expression language, which is how you define the languages, which is how you define the LangChain system. So next, in LangChain, they use tools as well. So tools are the actions, if many of you recall. And in this example, we are creating a tool to be able to call the database. So this is something like a RAG. So in some examples I've read, RAGs are also seen as agentic AI, but I think that is up to debate. So in here, in LangChain, you create a tool decorator, which you just put add tool as seen here, and that will already make the function a tool. So you name the tool, which here is multiply. So multiply, which is to take two integers and multiply them together. You have to give a description. So this is how the large language model understands what the tool is used for. And you give a schema of what the inputs are, which are just the parameters you input to the function and what you hope to get out. So next, that's how you create a tool. So a tool is an action that the agent can call. So now we need to create an agent, and as you recall, the agent needs the large language model, which is the brains of the agent. So here we can use an Anthropic model, so Claude 3 Sonnet, and we create an agent using this tool calling agent, where we put the Anthropic model, the tools, which is like multiply, and the prompt, which is something that you can use prompt engineering for the agent to be able to invoke the correct action. Yeah, so to execute the agent, you give it the verbose, which is the verbose equals to true, and this creates an executor. So what this executor does is it can take an input, which is the prompt, and output it to the correct answer. So this says take 3 to the 5th power and multiply. So this is something that maybe a lot of models will hallucinate, but because we use agents, it knows what tools to call, and with that, it can give you the exact answer. So now it's time for a demo, but before that, let's talk about some real world use cases. So the first one is Perplexity. I don't know how many of you heard about Perplexity, but I got this image from LangChain, which is the same thing as what Perplexity does. So if you send a prompt to the large language model, it will plan and then it will create some tools like web search, which is Perplexity. And finally, it will give you the answer based on these items that is managed to search from the internet. Another interesting thing is like code execution, which is becoming more and more prevalent. We have Cursor AI, Klein, and next is mathematics. which are the examples I've shown before. So this is another interesting example of agents where there is some human agent collaboration. So RAMP is something like Wise, which is a financial, which manages finances for shops. In RAMP, they have an agent to help you navigate through their UI, which I think is quite common, and ChatGPT really something similar. So something here says change my cart's branding, and the agent will actually work together with you to show you how you can do that. So although it doesn't do it for you, but in this way, where you have human agent collaboration, you can actually make sure that the steps you take are correct. So here you can see that it tells you exactly where to click, and you don't have to waste 5 minutes trying to figure out, and usually it's more than 5 minutes trying to figure out where everything is. Yep, so once you change the shop name, and then that's all you have to do. So this is RAMP. So now I'll move on to my demo. Before that, I need to change the title. So we are using Bedrock Agents. So in Bedrock Agents, to create one, you give it an agent name, a description. So for mine, it's a calendar input agent. So what it does is it converts an email message into a JSON schema for a calendar right into my web application. And you give it a role. So what a role is policies that allow this agent to do things in your AWS environment. So for the role, I've added access to Lambda, which is a function as a service. It allows me to process things. So in my Lambda function, I actually tell it to take the output from the large language model and send it to my EC2 to display it in my calendar. And here, I write the entire instructions for the agent. So when you receive an email message, it should pass the email content. It will call the Lambda function to store the title, date, start time, and description. And I'll even give it an example of what it's supposed to do. So next, we need to create an action group. So an action group is like tools, and what I explained earlier, we use Lambda for these actions. So a lot of times we use Lambda, but actually we can use other APIs, like even some where you call an API to figure out what the weather is in certain countries. You can actually create an agent to tell you whether you should bring an umbrella or you should pack your sunglasses. So here there's two types. You can define with function details, which is in JSON format, but I've use the API schema, which is OpenAPI 3.0.0. And so you define your summary, your operation, your description so that the agent knows what it's supposed to do, and a 200 response so it's successful, and the parameters that it requires to be sent. So for this agent to be successful, I need to send the title, date, start time, and end time and description to my EC2 so that I know that the application will run correctly. If not, if these objects are not stated, it will create a bad request. Yep, so now please email me something like this. You can use your own emails. Don't worry, I won't spam your emails, and you can block me. And for the dates, try to write it in this format. Don't use tomorrow or next week. If not, it will not work. Although there are ways for me to implement this function, but I didn't have much time, and also put the timing as such. So you need the date, the timing, and some kind of content. So now I will go to my own email. So this is how the calendar looks, but let me send an email to myself first. So here is basketball training, 26 March, 9 a.m. to 11 a.m., NUS basketball courts. So when I send this email, it should appear in my calendar soon, but it might take a while. Yeah, so let me go back to the slides first and tell you a bit more about my architecture while your emails are being processed by my agents. So I'm actually using Claude 3. I'm actually using Claude, but I'm not sure which version I'm using. It might be Haiku. So in essence, what I do is like the user sends an email to my domain name, which is Feathers of Kin. I'm using an old domain name that I have. And so this email, once it's sent to my domain, is actually stored in an S3 bucket. And in the S3 bucket, I create an S3 event action. So the events will trigger a Lambda function. So this Lambda function extracts out the information from my email and sends it to my Bedrock agent. So the Bedrock agent is the brains of the large language model, which will dissect out the points of the email where it needs to update the calendar, and it'll take the time like 9 a.m. to 11 a.m., the date 26 March, and some descriptions, which is really interesting. So that will send it to my Lambda function. And this function it will write into my Elastic file storage. So Elastic file storage is just like your Windows files where your EC2 can connect to. So since my EC2 are connected to all these files, if a user goes to the IP address, it will be able to see my calendar. So any person who puts in the IP address of my EC2 can see this calendar. So don't worry, it's nothing sensitive. So let's go back to my calendar. And interestingly, we see it right here, basketball training. So it wasn't here, location, NUS basketball courts. And yeah, and this is something else that I put for my dog. And here's another basketball training. So I really like basketball. And that is all for my presentations. So if anyone wants to find out more information about Gen C and our future events, please scan this QR code and please come. We got a Discord server also where we can discuss generative AI and machine learning content. And also my slides are available to download here. Yeah. And so here are a few references that I used to create this slide deck. Thank you.